Hi, my name is Rohan Sinha, and I'm a co-founder at Star Sensors LLC, where we develop a unique self-powered industrial IoT solution for downtime mitigation and maintenance cost reduction. So this concept of downtime, which I just alluded to, can be generally defined as any time period over which a piece of equipment is not able to perform its designated task. It's pretty straightforward, but it actually costs industrial players well over $20 billion every single year. It's pretty crazy. And the industry standard for solving this problem is called predictive maintenance. Basically, you employ some sort of technological solution, generally a sensor network, to try and guess when a fault is likely to occur and then make moves to try and prevent that from happening. Again, makes a lot of sense, but the adoption rate for predictive maintenance technologies is actually extremely low, somewhere in the ballpark of roughly 11%. The reason for this is because the existing predictive maintenance technologies can be bottled up pretty much into one or more of the following three bins. Many of them are simply just a data capture tool, which don't actually provide any insight on what to then do with that data. All the existing solutions are wire or battery based, which, depending on the variety of applications, it makes sense when that's not ideal, right? I mean, imagine having to run wires in a marine application or in a mine, or even having to send somebody up into a windmill regularly to change batteries. Obviously, it doesn't make a whole lot of sense. And then finally, the overarching constraint, of course, is cost. Many of the existing solutions are very expensive. Therefore, it's not justifiable to actually put these solutions on every single piece of equipment. Instead, they're only relegated to a few very expensive pieces of equipment. Pretty much this set of constraints is what informs STARS as we envision our solution to be a fully interconnected plant floor or industrial setting, built on the idea, of course, of having a self-powered sensor node, which eliminates the need for wires or batteries, a cloud-based analytics platform for real-time remote asset management, all while adhering to the core principles of being scalable, low price, and highly reliable. STAR's core technology was actually developed during 4 years of doctoral research at Case Western Reserve University. The idea for the project was pretty much developing a low power sensor node that didn't actually need a direct external power source. In other words, the STAR solution could, in theory, be attached to a piece of equipment and collect data and transmit it off device, powered purely by the vibration of whatever is being attached to. And pretty remarkable because that's actually what we've achieved here. The combination of the proprietary energy harvester, which is a piezoelectric technology, and the integrated circuit technology allow us to do just that. Here we have an image of our V3 prototype. It has an updated material and form factor in response to the feedback from our first successful pilot, the first energy plan over 8 months. And on the other side here, we have our software front end. The purpose of the software essentially is to analyze and visualize the data while simultaneously running a threshold-based alert system for maintenance triggers only when necessary. See, the long-term value for STARS is actually when we're able to closely interweave the software and the hardware component. From our own bottom-up calculations, we found that our total addressable market is somewhere in the ballpark of $3 billion. Our go-to-market strategy actually is broken up into 3 phases. Phase 1 simply involves running a high volume of paid pilots and trials. Phase 2 involves converting these paid pilots and trials to long-term contracts while we try and scale the number of sites that we're in and also, by extension, increase the amount of data that we're pulling in. Phase 3 involves using the data that we've gathered during Phase 1 and Phase 2 to roll out a very sophisticated deep learning AI and then transition the entire company's model to a hybrid hardware SaaS. At which point, of course, the revenue model would look something like a heavily subsidized hardware fee, an installation or integration fee, and then finally a recurring fee to maintain access to our software platform. See, STARS isn't a hardware company, and we're not a software company. We're an IoT company. And it's this vision that separates us most from our competitors, who is pretty evident didn't really look at it that way at first. Many of our competitors are very clunky, battery-based, and expensive. It's not ideal to scale or integrate across a full factory. And the team that's going to bring you this technology is pretty solid, if I say so myself. We have experience running the gamut, developing both hardware and software tools for commercial and academic settings, as well as investment and deal flow analysis. And if that wasn't enough to convince you, well, we do have some other stuff. Our core technology is actually funded in part by the Department of Energy. And it was first piloted in an 8-month field test successfully at First Energy in a study conducted by EPRI. As a company, we graduated from G-Beta, an early accelerator program by Generator, and of course, we're currently in the Clean Energy Trust University Accelerator. A little bit more on us as a company. Currently, we're trying to raise $65K in non-dilutive funds. This is to develop the software beta, explore alternate manufacturing methods, and of course, begin ramping up to conduct pilots. We're of course looking for intros into other core markets for both discovery and pilot purposes. So if anybody knows anybody that could be of help, I'd love to hear from you. Thank you. Once again, my name is Rohan Sinha. Thank you for listening, and I'm excited to hear your questions.